This video will give you a brief summary on the functions of the Central Processing Unit, also known as CPU. Computer systems are really complicated and you need to study computer mechanics for a few years to understand them fully. This video will only scratch the surface of how the CPU functions. I hope it will make you excited to learn more, and when someone talks about computers the next time, you will have an idea of what they are saying. The CPU is a little chip inside the computer's motherboard. You might ask, what is a motherboard? Well, a motherboard is a plastic board that keeps all the different parts of the computer hardware together. These include the plugs, the cooling system, the memory storage, the clock/heart, the graphics card, and lots of cables. That is really all it is. A plastic board with lots of cables just holding everything together. Some people call the CPU the brain of the computer, but I will call it more a robot arm that transfers one item from one place to another. The only thing a CPU does is transfer code or instructions from one place to another. The main components of this processing unit are a calculating device, a control unit, registers, caches, and a memory controller. The main components of the processing unit are a calculating device, a control unit, registers, caches, and a memory controller. Let's start with the control unit. The control unit's job is to load the code given to it and then to decode it. In other words, it has to read the coded command. After reading, it gives instructions to other parts of the CPU according to what the command tells it to do. The control unit decodes the coded command by translating binary code into microcode. Binary code is a number system with only zeros and ones. This works like a normal counting system, but instead of going from 0 to 9 before using double digits, it only goes to 1 before going into double digits. This is what it looks like. 0, 1, 1 0, 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1, 1 0 0 0, and so on. The microcode itself is very limited to just a few commands. Some of these are adding, subtracting, multiplying, and dividing. Inside the control unit there are also 3 small registers. Registers are little memory spaces where the computer can store data and commands. The 3 registers in the control unit have special names, and each store only one thing. The first register is called command register. It saves the command that is just being used. The second one is called command counter. It holds the information of the next command. The last register is called the flag register. It saves the status of the operation that is currently being executed. This brings us to the calculating device. This part of the CPU receives the microcode from the control unit and then sends it to the other parts of the computer hardware. This system is called Arithmetic Logic Unit, or ALU for short. The ALU sends information with the help of more registers. 2 of them are the data register and the accumulator. They give the ALU the information. Then a third register called function tells the ALU if it should add, subtract, or perform any other operation. The ALU then combines these 3 sources and produces the answer to the equation. This then gets written into the status register of the CPU. The last parts of the CPU are the memory controller and the cache. The memory controller is where all the commands and answers are stored, so the computer can access them if they are needed again. This is how a computer remembers shortcuts or the way you arrange your files on the desktop. It recalls this information every time you turn on your computer. The only problem is that the memory controller works a lot slower than the CPU. If the CPU needs a command quickly, the memory controller could not provide it in time. This is why the CPU has caches. These are little memory controllers that can give the CPU commands it has used previously a lot faster. It does not have to redo all the steps of reading the code and trying to find out what it means. There are 3 types of caches. The L1 cache is directly in the middle of the CPU. It can give back commands the fastest, but it's only around 128 kilobyte big. The next cache is just outside the center of the CPU. It is around 2 megabyte big. The third one is the farthest away. Because of that, it's also the slowest, but it's around 200 megabyte big. This, of course, differs from computer to computer. The older the information, the farther it will be moved away from the center in order to make space for new information. In summary, here's an example of how the CPU deals with a command. Let's say you would like to add 4 and 5 together. First, your command will be sent into the control unit by binary code, where it gets translated into microcode. If you already have tried to add 4 and 5, your CPU will recognize this and just activate the code it has memorized. If not, the command will continue to the ALU, which calculates the command and saves the answer into their cache. The next time you want to use the command, the computer can take it out of one of its caches or memory storage. It will then send the answer to other parts of the computer, such as the monitor, and make the monitor display the answer 9.